Okay, so we will start. So we did how to read the question, right? Okay. Right. So how to read the question, and you have to um how to read the question and how to convert to the mathematical notation. We did, right. So that is very important. Okay. Right. I'll just mute maybe. Okay. Right. How to read the question. We have that. Okay. So that's a easy one. So give me a second. There is a 2018 past paper, 2006 six past paper. There are many past paper. First, we have to read the question, right? First, we have to read the question and convert. Okay. First, we have to read the question and convert. Here, but I will give. I'll start with the one past paper question by converting. Then we will follow that, right? First of all, what you have to do, read the question and convert to the mathematical notation. Okay. Right. So this is the question. Okay, this is the question. Please read it and convert, and I will put the answer, and we will do this later. Okay. Okay. Right. Okay. So I'm going to put on the screen right now. I will give only 2 minutes or 3 minutes to read and convert. Please read the question, convert to the mathematical notation. If you follow my instruction, definitely you will get master this. You will master this relative velocity without any problem. Okay. Have you done? Anyone? At least one of you have done. That means read the question and convert to the mathematical notation. That's it. Not all, only a few things. If you read the first 2-3 lines, then you obviously you are able to convert. So not the whole. You don't need to read the whole question. Okay, right. So 1% done. So we come back to this. Right, guys. Here. So this is the question. So you have this 2001 past paper. If you have 2001 past paper, please just go through. I think you have the Pesuru. I have given all the Pesuru, all the sets of the questions. Right. See, a motor boat. See, read carefully because this relative velocity. Many students they found this is bit hard because they don't follow these steps. Right. That's why. So we are following that. If you apply that, definitely you will get good results. Right. A motorboat. Motorboat means share put M. Okay. Right. M motorboat. Motorboat. Right. Motorboat. Right. It's a motorboat. It's a motorboat whose speed is u. There is a conversion, right? Motorboat speed is according to Earth is u to the u is to this is u kilometer is to intercept a ship which moves with a constant velocity. Ship. So I say S is ship, right? And E is Earth. Better to write and mark. So then there is ships according to the Earth. That is V. Okay. In the northwest direction. The constant velocity in the northwest direction. See, this is west. This is what is that? This is north. This is south. You know, this is north, south. No, not south. Northeast. Northeast. You know, normally northeast, south, west. Okay. So what they say, northwest. Northwest means this is north. This is west. Northwest means 45 degree with this. This due means we have to mark the arrow in this direction. From means we have to mark in this direction. But they say in the northwest direction. So due in this way. Initially, if it is located, that is not the velocity thing. They give location right, and something like that. The draw velocity triangle. That's all. So what are the things you got? Only these two. These two. Okay, is it clear? These two. Later we will mark if you here velocity has normally velocity is the vector, it has magnitude and the direction. Okay, so for the initial at the beginning you are going to learn the relative velocity from the beginning. At the beginning, so since you are a beginners, I'm going to introduce right now. Whenever magnitude there, I call as a plus. Okay. Whenever magnitude there, I call as a plus. Whenever direction only there, I call as a minus direction. Whenever direction there, I call as a minus. Whenever magnitude there, that is plus. So this I'm going to use this plus and minus notation just to understand. Okay, just to understand. So after becoming a mastering this subject, you don't need that. Okay. Here, what do you have? Plus only. Here you have plus only. Here, V, that is magnitude. Direction is there. So you have plus and minus. Is it clear? Is it clear? Do you understand this? Okay. Whenever you have magnitude, you mark it as a plus. Whenever you have direction, you mark it as a minus. Whenever you have both, you mark it as a plus and minus. That's all. Okay. So in this question, something like this. Right. Very good. Okay, so that's it. That's it. I'm not going to mark anything other than that. Just that's it. Okay, right. I'm going to erase this. So we are good in uh, converting to the mathematical notation, reading the question and converting to the mathematical notation. So I urge another question because sometimes you may feel that okay, it is better to go through the another question. So I'm giving this question to you right now. Okay, so this will help you to do in a good. Okay, I'm going to. Okay, so this question, please read and convert to the mathematical notation. After that, we will continue to the our normal this thing. Right. 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 I'm going to share it. So can you see that one? This is 2006 past paper. Again, when we do this, we will do it again. So don't worry about that. Okay. So it says water flows in a river with a constant velocity u. Okay. So you can say reverse velocity with respect to Earth is u. That is given. So the first sentence you can convert to the mathematical notation. Between two straight parallel banks which are d meters apart, that is not related to velocity or anything. So that is related to the displacement. So that is the displacement things. Later we will do that. First now focus on the velocity. Done? Those who have done, please let me know quickly by writing done. Ah, you are there, no? After a long time, you came. Our hey, yeah. Well, so after long time. So reverse direction you can choose because reverse they didn't say which direction, but you can choose horizontal. Okay, done. Right. So I'll give another 30 seconds. You can read. At least you have to read. That's the thing. Okay. Okay. That's fine. So just reading now. Okay. This is 2006 past paper. We will do this kind of question again and again, because we will come back to this question. But before that, we need to know how to read the question and convert to the mathematical notation. See, first what they say, water flows in a river with a constant velocity u. So if they talk about the river or anything, they won't give the direction. You have to take the direction. For an example, if the river flows means you have to take it's like this, goes like that with the velocity u. So mathematical notation, river R with the respect to Earth, U. That's it. R means river. R is river. E is Earth. Later you can put these things. Second line says between two parallel banks which are d meter apart. Okay, that is physically you can you can mark this displacement things somewhere else. Now what they say, a boat moving with a speed to you. A boat be moving with a speed to you related to the water. That means Earth. Related to the water. That is river. So I say water is river. That is to you. Oh my goodness. Do you understand? There is no direction here. This required to take the straight course from the point A on a bank on a point B on a bank on other bank and back to A. Okay, so AB makes a certain acute angle with the upstream direction. So here you need to know some words, two words. One word is upstream. So upstream in 2016 they used that upstream verse. Again 2010 past paper they used that upstream verse. Again 2014 past paper they use the words, right? Sometimes they may use downstream. Upstream means okay. This is a river. Okay, so upstream means against that. Okay, So river flows in this direction. Upstream means against to the river. So in this direction. So makes an angle alpha means this. Is it clear? Okay. So A, B, this is alpha. That's why in the upstream direction. So hopefully. Okay. So upstream, they make alpha. So that is the velocity. So there is another one velocity. Indirectly, they say the velocity that both related to Earth, both related to Earth, it goes from A to B and coming back. So what you can do, it goes and coming back. So you can mark like this. Okay, so that is the one you need to know. Okay, so I can mark this here plus and minus, here plus only, here minus only. Only direction, there is no magnitude here. And I told you the last class in a certain in any kind of 99% of relative velocity question, 99% of relative velocity question. Okay, 99% of relative velocity question contains two unknowns. Okay, two unknowns, right? Contains two unknowns only. Two unknowns only. So any it can be any relative velocity question. 99% of those relative velocity questions have two unknowns only. Maybe they may ask magnitude of a velocity, missing velocity, or they may ask direction. That's it. So you can ensure that here, in this case, here plus or minus. Yes. Okay, no problem. Here I am missing minus. Here I am missing plus, two unknowns. Got it? Here I am missing, I'm missing my plus. Here I am missing minus. That means here I am missing direction. Here I am missing what do you call magnitude. So two unknowns. Previous one. So likewise, absolutely, there are two unknowns only. Okay, is it clear? Right. So I'm going to erase that. So keep this. I will tell another important note. If you can memorize, okay, no problem. If you can't memorize, also no problem. I will tell again. So what is that? You know this. Here. So the boat related to R. Okay. So if anything not related to Earth, if anything not related to Earth, see, most of the time they may give uh, magnitude, not the direction. Most of the time it's magnitude. Say to you. Is it clear? Right? Okay. So that is not a rule or certain thing. Just you can keep it in your mind and to work it out later. Okay. So shall I erase this? Okay, so there are 5 types in relative velocity question. There are only 5 types. The first type, right? I'm going for the first type. So now the first rule is reading the question, converting the mathematical notation. We are okay. So second one, we need to know what is the rule. Sorry, what is the type? So there are 4 types. So how we define the types? How we define the types? Okay, so you said only 2 unknowns. Okay, how 2 unknowns can define many type questions? So that's a good question, right? Okay, so I'll tell you. So very basic type. So equal type 1. Okay, type 1 question, very format 1. Okay, very basic type is something like this here. Okay, so this is a very basic type. So V equals V plus V, something like that. No, normally relative velocity principle, you know, no, something like this here, right? So very basic is plus minus given, and here plus minus given. You have to find this. Okay, that is a basic thing. That means magnitude and the direction given, magnitude and the direction given. So you have to find the other one, magnitude and the direction, 2 unknowns. So usually in physics question, you will end up with something like this. So I'll go for one example, then you will understand what I'm talking about. Okay, for an so shall I type 1, shall I put like this? Okay, distance, box and box. So it's a famous, very famous method to do this. But even though famous, you need to know the technique, right? Okay, technique is different always. See here, they give plus minus, and they ask this two unknowns. Can you see that there are question marks? Yes. How many question marks? Two question marks. If these two question marks in a one side, that means this is we call the type 1 very basic question. For an example, this with u, this with v, they will ask what is the velocity resultant or something like that. You have to find the direction and the velocity. So normally you have to draw the diagram. But diagram relative velocity the triangle. Okay. So you have to draw this. At the end, you have to draw this because you know this from physics. So you have to find this. So you have to find the angle. So say this is alpha, you can find the angle using the tan alpha. You have to find the length using the bilateral, you can find. So two unknowns, they ask, you can find two unknowns. This is a very basic stuff in under the type 1. Okay, so this is very easier because I use the Pythagoras. Why I use the Pythagoras? Because it's 90. Okay, adding the angle is very important, right? Adding the angle. Okay, so because it's a 90, so since this is a 90, so I can use the Pythagoras. If it's not 90, something any acute or obtuse angle, for an example, something like this, think about this theta, then I have to draw like this, see, this theta, then like this, see, this is the level. In this case, this is a bit hard. Okay, so you don't need to copy this. I'll tell you that, and just listen what I'm telling now. So I will give time to copy that. Okay, so if it's 90 degree, I feel better because I will end up with this right angle triangle, then automatically Pythagoras. But if it's something acute angle or obtuse angle, I will end up with something like this. So I have to find this length. You have to, most of the time you have to use the cosine rule. So if you don't use the cosine rule, you can do some arrangement, then you can do it. So most of the time cosine rule you have to use if anything acute or obtuse angle. So in that case, we call that is hard because you have to use the cosine rule. So this is we call is easy because quickly you get using the Pythagoras. So only that thing. So we call this is the type 1. Why we call type 1? So they everything given, plus minus given, plus minus given, they ask plus minus. That means they ask what is the magnitude and the direction of the same component of same velocity. Okay, same velocity, magnitude, and the direction they ask. So that's why we call type 1 question. So don't write that. I will give notes now and try to understand how types are coming. Now what I am going to do is see I erase. Okay, see I erase one question mark. I gave instead of that I put minus. Okay, so I erase then one minus here. I put one question mark. So see, can you see that? Hopefully you can. This kind of question we call type 2 question. How we do, how we identify this is type 2 question. See, how many question marks are there? Again, I'll ask, how many question marks are there again? Again, two question marks, right? This magnitude of this and direction of the other one. So only different is you are not going to find the magnitude and the direction of the same velocity. You are going to find magnitude of the one velocity and direction of the other velocity. That is the crucial point. So I'll tell you, I'll write the example. For an example, direction only given. For an example like this. Theta, direction only. Here, positive. That means magnitude only given, right? U. Here both are given. Something like this. Very famous. So in this case, we call this is type 2. Why is this type 2? Because the question mark is changed. So type 1 is a normal one, like a physics one. Type 2 bit dangerous. That means you have to work for that one. Under the type 2, there are methods to do. There are processes to follow. Under the type 2. There are four processes to follow to do the question. If you follow four processes without fail, answer. You will be with the answer. Okay, so that's why very structured. This relative velocity question is very structured. But we are learning is very structured, right? So if you don't do that, then you will fall in the miserable situation because you don't know how to draw a triangle and how to apply what to do, you have to draw the circle or not, but how to where to start, what to start, where to put something like that on the same diagram we have to start. So there are many things, but put all those things away. Follow this instruction. If it's type 1 question, that is simple one. I'm not going to discuss about that one because that's easy, right? If it's type 2, there are 4 things under that. So you have to follow those 4 things. Then only answer will come. So how to identify type 2? You know how to identify type 2. So question mark is not in the same place, different place, but something like that. This is type 2. Okay. So type 3. Type 3 means here. This is also question mark. Oh my goodness. Tell me. My goodness. This is also question mark. Then we have only few data. Only this one and that one. So the before I did the previous question, okay, the last question, previous that question, 2001 question, it is question it is under it is coming under the this third type 3, that is condition. So okay, so we found only 2 things. See, have you noticed that previous 2001 question we did converted from the scenario to the mathematical notation, only 2 things. So that's like this. So tell me, will be able to do this type of question? No. Why? Definitely no, because we don't know. We have 3 unknowns. I told you you have only 2 unknowns to do. So here 3 unknowns. Then we can't do it. So if we can't do, why they give us a question? So that is good question. Say if we can't do, why they give us a question? So then I'll tell you these kind of question they will have definitely the condition. So there is a condition. There is a condition. Okay, they will have definitely a condition. Maybe it getting closer, or it smashing, or collide, or going away. So it's try to maximize the speed or something like this. Conditions. Okay, that condition brings the negative. The condition bring most of the time, 99 percentage. This condition will bring the direction. For an example, I will tell you one car is going okay in this direction, another car is going somewhere in this direction. Okay, the condition is this car goes must meet the car. So, or then if you okay, so this car is going in this direction, it's going in this direction. Okay, so if you stop this, what happens? Then to meet this car must come in this direction. No, according to this car must come in this direction if you stop. So that means the condition. What is the condition? You said they must collide. Okay, the collision should be there. So then I stop this and I need to draw the direction of this according to this in this. So that automatically give the minus. Okay, so that's why we can do this. And then the final type 4. Type 4 means okay, so this is not given, and this somewhere here, this is also not given. See, 4 unknowns. If it's 3 unknown, we can't do. We need something, any other support. But 4 unknowns, what to do? In that case, you know, I'm asking one question. Will you able to solve this question? 2x plus y equal 3. Can you solve this equation? No, you can't solve this equation. Why? Because 2 variables, x and y. So only one equation, how to solve that? So if you put 1 for x, y will be something else. If you put 2, something else. So you can infinity many solution to this question for x and y. What is that? Infinity many solution for this question for x and y. So you can't solve this. So but if I give another equation like that, so 5x minus 4y equal 4. So then we can solve these two. Why? This becomes simultaneous equation. That is that is true, right? So if the equation alone you can't solve, but by considering another equation we can solve. That is we have learned in all levels, simultaneous equation or simultaneous equation. Similarly, if 4 unknowns are there, we can't solve, but there will be another condition with another 4 unknowns. and maybe this may be same, and something like that. So joining those two, that is most of the time you have to join those triangles, velocity triangles. Okay. So by joining them, you can use like solving the simultaneous equation. You can find. So these are the four types in relative velocity. That is the end. The fifth one is there. I just tell that is crossing the river, and the vector type questions also there. So the exercise is so long that is over 25 years we haven't uh, they haven't put the question. But uh, other one, 2000 past paper they put in crossing the river, I think. So that we will learn. Okay. So other one, the last one, vector one, we will do in a paper class. Okay, we are not going to learn as another type. We will do in a paper class. As a question we will do. Okay, so then most of the time five types. We can say five types. Okay, so you understood. So first of all, just for the understanding, now we'll start to write the notes. Okay, then we can do one exercise in type 1. Okay, we can do one exercise in type 1. Right, now type 1, put the type 1 and draw this one, box and box. Now you have idea, because I have given the idea. So now if I give a notes, then you will understand. Okay. Okay, under the relative velocity, I will give 2 points. Did I tell? Under the great development principle, you told I give 2 points. I don't know what points. Did I? I forgot it maybe. So maybe this time, this thing. Maybe, I don't know. I forgot it actually. Okay, 2 points was 2 points. Under the relative velocity principle. Uh, I think, yeah. Right, right. Right. Okay, okay. Under the relative velocity principle, okay, yeah. Yeah. Write down examples before this or after this or somewhere else. Write down examples. Wherever you write examples, you need to please you have to look at that. Okay, that's why I call exam tips. Okay, exam tips can be before the heading, after the heading, in between, no problem. So exam tips, write down. Okay, so under the relative velocity principle, okay, what we have to do. So first of all, most of the time, you have to start the relative velocity principle with the minus. Okay, that means direction only. So write down. Now, if you know minus, no. So if I say minus, you will understand, no. So start, write down. Start the relative velocity principle with minus known only. That means minus known only. For an example, see velocity PE something like this, and say velocity WE something like this, say velocity PW something like U. So see, this is minus, this is plus, this is UV. Okay, plus or minus, and this is plus only. So now, after reading the scenario, you got something like this. So now the next point is, next task is how to start the relative velocity principle. So from where? That is the challenging one. No? From here, here. From which one we have to start? So that's a challenging one. Initially, that's a challenging one. So that's why I give a solution to that one. Here, this is minus. That is direction known only. This is plus and minus, both there. This is plus only. That is magnitude only. So we have to start always from the minus. That means direction known only. That means you have to start with this. VPE equals PW plus W. Very important, no? Very important exam tips. Yeah, I know that. The value of this exam tips is very important. Very, very important, because many students, they struggle to start. So how to start, where to start, when to start. So no problem. So most of the cases we have to start with the negative. So you can start with it. Only the fourth type question only, you don't need to start with that. I will tell at that time. Okay. So before that, always you have to, after reading the scenario, you convert to the mathematical notation. After the mathematical notation, you see some set of data like this. Then you have to write the relative velocity principle. Then from where you have to start is choose where you see only minus, negative only. So then you can start. After starting this, you will realize which type, whether it's type 1 or type 2 or type 3 or type 4. So if it's type 1, okay. Type 2, there are another 4 process. We will do that. Then if you follow that, answer. If it's type 3, there are 3 process. If you follow that, answer. If it's type 4, there are 2 process. If you follow that, answer. That is end of relative velocity. So it's a complete picture I have given to you. Okay, so all are structured because I know that, and we know that from the experience of the students and for long years and the past papers and everything, students struggle in this relative velocity because they don't have a clear idea and they don't have this structure. They have some many cases they have in syllabus also they say this is type 1 type 2 and something like that, but there are these kind of clear picture. After that you have to further, you have to divide and go. So if you handle, then okay. Okay, right, is it clear now? So exam tips one is you have to start from the minus. Second one is when you want to stop anything, any particle or anything, so you have to stop which has the magnitude and the plus, which has plus or minus. So if the plus or minus is there, you can stop. That person only you can stop. If negative only, and the only direction having, then don't stop that person or stop that particle. Don't stop. Only magnitude having, no. So which has the plus and minus. That means magnitude and the direction. So you have to stop that particle or person. Okay. So that is exam tips 2. So when you want to stop, so if you want to write in like a good language, then you can write when you make it a frame. Okay, so according to the relative velocity or something like that, you can use. So normally if you just wanted to know, to clarify with yourself, just you can write, if you want to stop a particle or anything, you have to stop which has magnitude and the direction in bracket plus or minus. You can write, I'm not giving as a note because every time I'm going to tell this. So then if I recite what you will understand that. Okay, so hopefully, is it clear? Is it clear? Right. So I'm raising. This is example, I'll tell you. So type 1, just write down this one, this one. Type 1 question. When you read the question and convert to the data, you will have plus or minus, plus or minus. Now you know what is plus, what is minus. Example, write down example. Velocity of A related to Earth is U. Velocity of B related to Earth is V. Question is velocity of A related to B. Do it now. Do it now. Now we have to start from the minus. No, there is no minus. No, then you can start from anything here. This one or this one or this one. But here, this is the one. You have plus minus here, plus minus here. This question is you have to start with the question because they ask the direction actually. Normally, magnitude easily we can find. The only problem is adding direction is the problem. Adding direction is the problem. For an example, if U is there and another U is there, so I can say to U. So adding direction not a problem in this case because same direction you just add the magnitude only. If it's opposed, if it's 2U, if it's opposed, then you right against opposite direction also you add the or subtract the magnitude only. Okay, because same or opposite direction you add the magnitude or subtract the magnitude. So no problem. So adding the direction is not a problem here. But if it's something like this, U is here and another U is there. So how you can add this? How you can add this? So you can't add these two because these two are in a not the same direction or opposite direction. So in that case, you have to go here, and then you have to find this length you have to put. So that is the direction. This direction magnitude. So that's why you have to write root 2 u. Is it clear? So that is the basic concept behind the adding and drawing the velocity triangle. Okay, anyhow. So we'll start with VAB. So, okay, shall I? Okay, I can do it here. VAE plus EB. So it's there? Yes. So you can see AE is somewhere here U, and EB is BE upwards B, EB downwards B. Need to know about this. Now what we have to do, you have to build the velocity triangle. That's physics. There is no space here. I can use this one. U and V. So this is the resultant. Or respect to B, A's velocity is this. So using the Pythagoras, so this is the answer. If it's theta, you can put tan theta V over U. Later it goes theta tan inverse V over. That doesn't matter. Do you understand, guys? Quickly, you can find the magnitude and direction. Only two unknowns. Any relative velocity questions. Guys, do you understand this? I'm just speeding because just, you know, you need to know. You are okay now. Hopefully. Yes. Comprehensive. Okay. Now the problem comes. Why? So now only 90 degrees. No. So if it's come any angle, what will happen? It will. So in that case, what do you do? If it's any angle, what will happen? What do you do? Any problem? Let's see, I can give one question. Then you can convert to the mathematical notation. Then you can use the relative velocity principle, and then you can draw the velocity diagram also. I hope you will do that. Let's see. I'm coming with another question. Let's see. If my question is here, then definitely I will put on the screen. If it's not there, what to do? I'm thinking one question. Mm, okay, so this is the one. So what I'm going to put here, just read the question and convert to the mathematical notation. Okay, just read the question and convert to the mathematical notation. Later we will. Mathematical notation, and you have to draw the diagram also. Let's see. Up to certain level you have to go. Let's see how you can do this one. Yeah, you can use that, but rather than using that, it's better to use the cosine rule. Cosine rule. Don't use this vector thing. Use the cosine rule. Okay. Just read it. A destroyer is sailing the warship. Yeah. Yes. A destroyer is a ship warship, right? It's sailing north at a constant speed of u at night, 12 o'clock, right? On a certain day, the destroyer, that means the warship, sights an enemy vessels d-kilometer east of it. The enemy vessel is sailing in a direction. Convert to the velocity. That means mathematical notation. At a constant speed of v cos theta greater than u. Show that the enemy vessel will be at the least distance of this after the time this, right? Okay, so we will do this one. So I'll give another 1 minute to do something else. Only thing is you can, get rid of this statement or scenario after you converting to the mathematical notation. That's it. Okay, mathematical notation and the ground drawing, right? Okay, guys. So we will. Okay, we'll try to do this question. This question says, okay, read by reading the question. What we have to do? Okay, by reading the question, you have to convert to the mathematical notation. Say a destroyer. Destroyer means say warship. Say warship. Warship. So that is the destroyer. I take that as a destroyer, right? Or I can put D also, destroyer. Sailing north at a constant speed of u. Sailing north. That means due north. So warship W respect to Earth, north u. That's it. Conversion is finished. One conversion is finished. At a okay, so on a certain day, the destroyer sight the enemy vessel d-kilometer east. That is a displacement. So where is this Earth's frame? I guess I just put Earth's frame here. Earth's frame. Okay, Earth's frame. So Earth's frame. What they say? This enemy vessel is sailing. Sorry, and the destroyer sights an enemy vessel d-kilometer east of it. East. Here. So this is destroyer. That is warship. This is enemy. Hmm. I'm not going to mark E because already I'm using E as a Earth. Yes, the earth I am using. So shall I put as a boat BB? That is enemy. BB boat. Okay. So I'm on. So at the certain this is of Earth's frame, this guy is going with a U, and it's no, its sides are is it? Mm. B kilometer. And this guy is I don't know what they say. Sailing at a constant velocity U east. Sailing east at a constant velocity. No. There is a small mistake. Yeah. Now the enemy vessel is sailing in a direction theta W of north. Constant speed of V. Okay. W of north theta. Something like that. That means west of north. How you can read this? West of north theta degree. So that means this is north, this is west. So west of north is this direction. With this is theta. Understood? That is the idea of this. And it's with the velocity v. Okay, so this is what happens in the earth frame. Okay. Then I can mark here that is B enemy travels in this direction with the velocity v theta. Okay, any problem? No. Now the constant speed of v, since v cos theta greater than u. So they say one something more, something v cos theta greater than u. So v cos theta greater than u. Why they give that like that? I don't know. Let's see. When we draw the triangle, it will help. That's right. Okay. So what they say. Show that the enemy vessel will be at least the distance. Okay, this guy is not going to destroy it. Okay, just going very near to that boat. Okay, so first of all, this is the earth frame. So I'm going to stop because why I'm going to stop? Actually, this is not, I say this is a type 1 question because you know this and this, you can find the other one according to anything. But it's really, this is coming under the type 3. Why type 3? I have only two here, plus minus, plus minus. So two unknowns are there. I have to find another two unknowns. See, that is nothing. I don't know. And I have the condition. What's the condition? Very close. Okay, they are not going to meet, but this guy, they are going to be very close at a certain time. Okay, so that's why the conditions. Condition means you have to stop. So in this case, you have to stop a person because we can't lose because we are without stopping. So which one you have to stop? I told you in exam tips 2. If you want to stop anything, you can stop anything or any person or any particle, but they have to have with the magnitude and the direction. They must have the magnitude and the direction, not the magnitude only, not the direction only. Then only you can stop or you can find according their frame. So here both I know. This is also we have magnitude and the direction. That is also having magnitude. So the convenient is this because rather than stopping this is easy. So I'm going to stop this. That means that now I'm going to draw W's frame or frame of W or frame of warship or frame of destroyer. So in that case, what happens? If you want to stop anyone, you can draw like this. If you are stopping, this means this person is stopped or this particle is stopped. So when you draw like this, so that means it can't move. This frame, W's frame. This is the W, this is the B. So if the person B has to meet the W, then he has to come in this direction. That for the meeting. But in this question, they didn't say about meeting. So they say something like that. So without drawing any diagram or anything, using the first class knowledge, the first class knowledge means we had to stop the plane and everything. So take something from the person or point. or particle, then make it opposite to give it to other stuff. So if you want to stop a person, that means if you want to stop, take the U and make it opposite direction and give it to other particle, any particle. So that means it's going to be like this. This is V theta, this is U. So V cos theta, V sin theta, if you can just resolve. This is V cos theta plus. Say, if this V cos theta equals U, if V cos theta equals U, definitely this will travel in this direction, they will meet. Okay, but in unfortunately, in this case, they say V cos theta greater than U. So V cos theta minus U will be there, upside. So it's moving in this direction. Is it clear? So that is the meaning of V cos theta greater than U. So this, according to this, B moves in this direction, not down, not coming to us. If V cos theta equals U, definitely this will be 0, so it will come in this direction. So anyhow, so how to find this velocity related to this? According to the W, the velocity of B, how to find using the triangle. Here, we stopped one thing now, so that means velocity, we stopped W. According to the W, velocity of B, we have to find it. We have to find it. So how to find it? We have to start with this. So, right. So what we can do, using, write down, using relative velocity principle, we will start with if W is stopped, velocity of B. So we know that, but officially we have to write now B E W. Why we have to stop anything? You can stop B or you can stop W. I stop W, that's why I'm writing BW. BE known. That is theta with V. Okay. EW, this is U. So EW is downwards U. So now we are going to draw a velocity triangle for this one. Okay, this one short method I used and I found it. So I'm going to erase this one. Everything I'm going to erase. Okay. Still I don't know velocity of B according to W. So from here only I have to find. I know that officially I have to find out from here. So then you have to draw this velocity triangle. How to draw the velocity triangle? First we have to start with this. See here. Okay. I'll start with this. Okay, all right. Oh, I can erase this. Now I don't need this. E cos theta greater than U. That is the only thing I need to apply. Velocity triangle, and first we have to start with this. Okay. So it goes that. Then you have to, at the end you have to start this. So at the end means here. So where I have to stop, here or here or here, I don't know. But they gave one thing, V cos theta greater than U. So this is V, no? This is V. So this is theta. Why? This is theta, this is theta. So if I draw 90 degree here, this will be V cos theta. V cos theta. But they say V cos theta greater than U. So U must be less than that. Somewhere here I have to stop. So this is U. So I erase this. Do you understand? This is U. This one U. I stop here. That's why I have doubt where I have to stop, here or here or here. Now I decided to stop here because V cos theta must be greater than U. So U must be less than that. Okay. So that is the only way. So now the resultant I draw with the red. This is the resultant. Double arrow. Double arrow. So this is the velocity triangle. Okay. Just you can copy this quickly. So if you want, you can make it up. Put the dot line, dot line. So you can say this is V sin theta. You can say this is V cos theta, then this is V cos theta minus U. This is V cos theta minus U. This is V cos theta, this is U, this is V cos theta minus U. You can find this using the triangle. See, by the errors. Rather than using the cosine rule, you can find like this also, but it is better to use the cosine rule. So I say this is W. Okay, so then I have to find that. So now I can erase this. So hope you copied this, right? You copied this. Just up to now, I'm just leaving here. Just I'll give 30 seconds or maybe 1 minute. This is a web frame. Okay, one side you have to draw like this. One side you can show this. No problem. So you don't need to show. You don't need to wait until it's finished. This one you can divide the book into two portions. One portion you can show this relative velocity principle. One portion you can show Earth frame. Right? The rest doesn't matter. Or you can start with this and you can end. Or you can start here and later you can put whatever, no problem. Okay, so you drew the velocity transfer. First copy this because I'm going to erase this. Because now I don't need this. See? I don't need this. Okay. So what is I have to find what I have to find since this is the first type. Why is the first type? Two unknowns of the same velocity. What is the two unknowns? Magnitude and the direction of the same velocity. Understood? Here, this is the one unknown. This length unknown, that is magnitude. This direction unknown, that is say this direction is alpha. So this is alpha. Say that alpha is here with the horizontal. If this stop, what is this? What is this? Velocity of the B respect to W with the horizontally alpha in this direction. So you can draw that. It goes like this. Is it clear? This is D. This is a displacement triangle. This is velocity triangle, but direction must be same. If the particle move, according to this W, V moves in this direction, means because of this velocity. Okay, same alpha, same parallel. Okay, so I have to find the W. Use the cosine rule. Say PQR. So for triangle PQR, you can use the cosine rule. Okay, so or you can use the bidirectional. Here, this plus this. So I use the cosine rule. W squared equal this square plus this square cos theta. U squared plus V squared minus 2UV cos theta. That's it. Finish. One step answer. If you want W, you can take the square root. If you want, you can take the square root. I keep that. And how to find alpha? Then to find the alpha, you can use this. See, sine alpha is this over W. V cos theta minus U over W. Or this over this. Tan alpha. Or cos alpha, V cos sine theta over W. Whatever thing. If it's cos alpha, whatever thing you can put. So you can find the alpha also. Now we come to the final answer. So answer to this question. What they say, the very closest, that means, what is that? What they say in that question? Least distant. So least distant means here at the initial that is the distance D. Now this guy doesn't move. According to this guy doesn't move. This moves. Here, what is the distance? Here, this one. After some time, this one. After some time, this one. This one. So then the distance will be least the perpendicular line if you draw this. This is the least distance, this one. So this can't move now. When 12 o'clock night is there, somewhere after some time it's somewhere here. So at that time, this is the least distance. So they ask the time traveling. First we will find the least distance. So I have to find this, say x or anything, I have to find it. So easily I can find x is d sine alpha. So this is d cos alpha, this is d sine alpha. So I can write, now I can erase Earth frame or everything. Okay, I can erase this. Okay, so I can follow this. So x least, say least distance equals d sine alpha. That's it. What is d? What is sine alpha? Here you can substitute this one. V cos theta minus u over w. W is square root of u squared plus v squared minus 2uv cos theta. Is that answer? Is it answer? We'll check that quickly. Least distance is that answer? See? Yes. d into v cos theta minus u over square root of u squared plus v squared minus 2uv cos theta. Okay, right. So that's the answer. Now time taken. Yes, of course. Why not? Should be, right? Time taken means from here to here. So we have to divide this distance. See, this distance, that is v cos alpha, divide by that velocity. What velocity? W. You can divide this distance by that velocity. Okay, that is the normal method. If you are a very technical person, you can choose many other methods also. See, you can draw perpendicular here, this one. So from here to here means here to here, right? So this distance, if you can find this distance, so that is if you can find it. So this is d cos alpha, d cos alpha, cos alpha, d cos alpha, cos alpha, then d cos square alpha, d cos square alpha divided by this portion. This portion of this is d sin theta. You can put like that also. This portion divided by this velocity. Okay, that is very advanced. Okay, I'm not going for that one. Very easy one, I'm going for that one. What is that? D cos alpha. You divide d cos alpha by W. So time taken. So I'm going to erase this also because I am going to simplify that. D cos alpha divided by time taken. Time taken. D cos alpha divided by W. So I'm going to substitute. Don't substitute for the cos alpha and W separately. Don't do it. Why? Because cos alpha, I know that cos alpha V cos theta over W. So you can dW dot. Instead of cos alpha, you can substitute V sin theta over W. V sin theta over W. So it's W squared. So dV sin theta over W squared. W squared is exactly this one. U squared plus V squared minus 2uv cos theta. Is it clear? Do you understand this one? Quickly I'll tell. Okay, so if you can understand, no problem. So, okay, can you explain W square equal? Okay, cosine rule, man. Oh my goodness. In this triangle, cosine rule. This is U, this is V, W. So cosine rule is W squared equal U squared plus V squared 2uv cos theta minus cosine rule, cosine rule. Okay, so length. Think about these are length. U is the length, V is the length, W is the length. Don't think about thing as a vector now because I use the direction here. Here I'm using the direction. Okay, right. So the lengths, these are lengths. Okay, guys, is it clear? So this is a type 1 question. So I think today is enough. Very long explanation and the questions, and from the past paper we have converted to the mathematical notations. Then we converted to this thing. And one question is done. So next class is very important. So that is very, very important because 70% of questions coming in the past paper coming in under the type 2. And 20%, 25% type 3. So these kind of things only 1 or 2 past paper they put at all. So now if you want to do check yourself at this moment, you can do 2007 past paper. What is that? 2007. Okay. If you have O Pesuru is there, always you can go through. With this knowledge, you can do 2007. Okay, hopefully. We will meet in coming classes. The next class we will meet in relative velocity. Sometime I may put some extra classes in between. Please be ready and please cooperate with me. If I want to finish certain section quickly, then I will do it, right? So that is according to the situation, right? Okay, guys, I'll always be on. Good night, hopefully, and let's see, right?